Welcome to the world of Mechatronics. My name is Ng Ping, a lecturer from the Automation and Mechatronics System course. I'll be giving you a lesson on robots in the mechatronics world. You will learn about different types of robots that exist in our daily lives and its applications. You will also learn how an industrial robot works and the design control chain behind it. We will then be focusing on the pneumatic control mechanism of robots and how it works. If you decide to choose our Automation and Mechatronics System course, you will learn the emerging skills needed for this new digital revolution in robotics and automation, design thinking, Internet of Things, and data analytics. So what is mechatronics? Mechatronics is an engineering discipline which integrates mechanical, electronics, and programming knowledge with the aim of designing smart machines, just like robots or anything that helps to assist us in our daily lives. Nowadays, you can find robots everywhere, from homes to parks to hotels and also the factory. At home, some of you may even have the iRobot or the Xiaomi robot, where it assists your family to clean the floor of your house. When you go jogging in the Bishan Ang Mo Kio Park, you may even see a cute yellow robot running around asking people to keep a safe distance from each other. In some hotels, you can even place order for the robot to cook an omelette for you. In Japan, you may even have robot preparing you some sushi. And when you have an industrial visit next time, you will find that industrial robot arm is a common sight. Today, we will be focusing on industrial robot. What is an industrial robot? It is a robot system designed and programmed to replace repetitive or dangerous tasks. Take a look at the Mitsubishi robot as shown in figure 3. This is just one of the robots we have in our school to teach our students on how to program it. What does this robot do? Basically, it picks up a workpiece whenever the retainer detects it. It will then assemble this workpiece by putting a piston, then a spring inside it. Eventually, it will then put a cap on the workpiece to complete this process. This robot station can be customized according to our application needs. Let's watch this video first on its assembly process as shown in figure 4. So you can see the student loading in the red workpiece and pressing the start button. So the robot arm picks up the workpiece and put it in the assembly retainer. So now it picks up a black piston and put it inside the workpiece. It now puts a spring as well. And finally, we put a cap on top of the workpiece. So we now place the workpiece on the dispensing chute. Now, I'm going to focus on the initial operating sequence where the robot picks up the workpiece. So how does the robot know that there is a workpiece? Well, there's a sensor at the retainer. So when the sensor senses that there is a workpiece, the robot arm will know. The robot arm will then come down to the retainer teach position with its gripper open to pick up the workpiece. You will then close the gripper to hold the workpiece. Eventually, you will bring it to the assembly retainer module to assemble it with piston and spring. Do you know what is the operating mechanism of this gripper? Well, it is operated by Pneumatic Technology. So what is pneumatics? Pneumatic means air, and in this case, we are using compressed air. Later in the lesson, I will focus on pneumatic control. As you can see in the earlier example, the robot first senses that there is a workpiece present in the retainer. Then it will execute accordingly to what is being programmed. This is what we call the product control chain, where it always started off with input elements. which is like the human senses, the eyes and the ears. So the sensor on the retainer is like the eye of the robot. It knows that there's a workpiece there and it has to pick it up. Other types of input elements include buttons such as our lift buttons or even touchscreen. The next step in the control chain will be the signal processing element, which is the brain of the system. In the example of the robot, the brain is the robot controller, which houses the program. The program decides how the robot should move. Other examples of signal processing element are Arduino board, Raspberry Pi, or even programmable logic controllers, which are commonly found in the industry. The final step will be the output elements, which is like the arms or the legs of the system, which move. Just in the case of the robot arm, it is driven by AC servo motors. The pneumatic gripper is also one of the output elements of the systems. Other examples of output elements are also DC motors and pneumatic cylinders. We can see earlier that the robot arm is a product which uses various technologies. We will now focus on pneumatic technology and see how this is being applied in other automation process. In our daily life, we often take bus to work or to school. Did you notice the operating mechanism of the door? Well, they are operated by electro-pneumatic control. Electro means electrical, and pneumatic, as I mentioned earlier, is compressed air. All the doors have safety sensors to detect the presence of human. Hence, if there's someone standing in between the door, it will not close because of the sensor. Let's take a look at figure 5 to watch a video of a bus carnival at Ulu Pandan, where they showcase how the pneumatic cylinders are designed to open and close the bus door. So you can see the pneumatic cylinder here extending and retracting to close and open the bus door. Earlier, we know that the robot gripper opens and closes because of pneumatic control. We also learned that the bus door is operated by pneumatic cylinders. So how does a cylinder works? Well, in figure 6, we are showing you a cylinder with 2 air ports. We call it double acting cylinder. Let's watch this short video on figure 6. Over here, you can see that this is one of the cylinder you can find in our lab. Okay, this is the ball side of the cylinder, and this is the rod side of the cylinder, as you can see. Okay, so these are the air port. Okay, so over here in the air port, you'll plug in the pneumatic air tubing. Okay, and over here you can also plug in the pneumatic air tubing for the rod side of the cylinder. Okay, so where are these tubings going to be connected to? Later on you will know that they will be connected to the directional control valve, whereby your directional control valve will be connected to the air manifold, or we call it the air supply, so that the cylinder, when there's air coming in from the ball side, which is here, it will extend. Okay, you can actually see extend. Okay, however, when there's air coming in from here, the rod side, you can see that the cylinder will retract. Okay, so think about this. What type of cylinder is this? Okay, as I've told you earlier, this is a double acting cylinder because it has 2 air ports. So now we have learned how a cylinder works. However, how does a cylinder extend and retract automatically? Well, that's where you need a directional control valve. The directional control valve will enable the air to be pumped either into the ball side of the cylinder or the rod side of the cylinder. Let's watch this video on figure 7, which explains to you how a cylinder extends and retracts with the help of a directional control valve. Now I'm going to show you the double acting cylinder, okay, and how I'm going to use the directional control valve for 2-way double solenoid directional control valve to control the extension and retraction of this cylinder automatically. So first, I will draw the solenoid on this directional control valve. Solenoid 1, SOL1, and solenoid 2. Okay. Next, I will draw the air supply that's being connected to this DCV and the exhaust as well. Okay, and this cylinder is being connected to this DCV using pneumatic air tubings. So one side to the ball side of the cylinder and the other side to the rod side of the cylinder. Okay, so now when I energize solenoid 2, you will activate this checkbox because this checkbox is closest to solenoid 2. So the air from the air supply will pass through this DCV and go to the rod side of the cylinder, causing the cylinder to retract, and the air will then come out from here to the exhaust of the DCV. Okay, next, to make it extend, I will first need to de-energize solenoid 2, okay, and energize solenoid 1. So this DCV will switch, okay, because you will activate this box, because this box is closest to solenoid 1 and you have energized solenoid 1. So it will switch to here, and you can visualize that the air supply will pump in the air to the ball side of the cylinder, making the cylinder extend. Okay, and the air will then come out from the rod side to the exhaust. So how do I make the cylinder retract again? First, you have to de-energize solenoid 1, okay, and energize solenoid 2. When you energize solenoid 2, you will activate this checkbox because this checkbox is closest to solenoid 2, and you can see that the air supply will pump in the air to the DCV to the rod side of the cylinder, causing it to retract, okay, and the air will come out from here to the exhaust. So this is how the DCV can be able to use to connect to the cylinder to control the extension and retraction of this cylinder. So with this, I hope you understand how does a DCV works. And just in case you wonder what's the layman term for energize the solenoid, it just means that you give power to the solenoid. So in this example over here, we are actually powering solenoid 1 and 2, okay, and by powering solenoid 2, the cylinder will retract, and if you power solenoid 1, the cylinder will extend. So now I would like to summarize today's lesson. You have learned about different types of mechatronic robotic products and their applications, different parts of the industrial robot arm, understanding the control train of mechatronics products, and how does a cylinder work and how it switches its direction automatically. Now I would like to go through in details of what we can offer you in our Automation and Mechatronics System course.
Hi everyone, my name is Ms. Tan Lei Fong. I'm a senior lecturer in Ngee Polytechnic, teaching Automation and Mechatronics System Diploma. Let me walk through with you what the AMS course is about and what awaits you in the course.
The Automation and Mechatronics System course is a broad-based course that blends mechanics, electronics and programming to equip you with the skills for the new industry. These are the emerging technologies that you'll be learning in the Automation and Mechatronics System course. In the first year, you'll be building your foundation in engineering and mechanical modules. In the second year, you will be deepening and broadening core knowledge in automation and mechatronics. Finally, you will have the opportunity to learn advanced robotics and automation before embarking on an internship program or a final year project.
Follow me to see some of the interesting modules that our AMS students study.
Augmented reality is not just about fun and games like what you have seen in Pokemon Go. You also have a variety of users in industrial automation. In its simplest form, AI is used to identify a component, machine, and give the user some information about it. This information can be anything from websites, datasheet, or even videos to Industrial Internet of Things data. With a mobile device using AR, the technician or operator is able to find the details of the parts easily and quickly. Students will learn in our module to create AR applications to illustrate and train operators to learn more about the machine without the need of a training manual. Other than learning how to use AR technology to create applications to assist workers, you will also learn how to configure, adjust and program to control mechatronic system with the use of programmable logic controllers, which we call PLCs, and integrating machines to the Industrial Internet of Things network using OPC-UA and smart sensors for data collection and control, which is part of Industry 4.0 Smart Factory.
Let's see our next interesting module.
Ever wonder how a robot is programmed to do its automated tasks in a factory? If you'd like to learn how to program a robot to be able to see and to carry out its automated operation, then the module Industrial Robot Systems and Application is definitely for you. The third year module focuses on enabling skill set to integrate and implement industrial robot for manufacturing industry. Students will be introduced to fundamental concepts of industrial robot arms. These include robot configurations, robot coordinate systems, and transformations of frame references. To complement robot operation, robot perceptions in 2D and 3D will reinforce through programming exercise using robot operating systems. If you also like to know how the cutlery collections robot in the food court is able to navigate around without human control and able to detect obstacles along its path, our integrated real-world projects, autonomous vehicles, and mobile robot will offer a full insight of how this marvelous machine works. In this hands-on module, students will have the opportunity to build and assemble an automated mobile robot from scratch. They will learn on the key components such as motor, controller boards, light detection and ranging sensors, electric circuitries, and mechanical structures that made up a mobile robot. They will also learn how to implement autonomous capability on the robots using software packages that will allow the robot to map out its environment, do obstacle detections, and navigate by itself to the destination.
Have you thought what it's like living in a smart home using gesture to turn on lights? Or if someone enters your house when you're not at home, or the blind will auto-open during the daytime. Students have the opportunity to learn Internet of Things and controlling them using node programming. You will also learn how to set up cloud server to collect data, use SQL to query table, and visualize data with live data. There are many uses for Internet of Things. It is not only used for home office application. In the Automation and Mechatronics System course, students apply service learning to use what they have learned to help the community, such as elderly living alone in their home. We also learn Industrial Internet of Things for factory automation. Look at this camera. The image and video captured by the camera can be used for computer vision application. Students will learn image processing techniques to enhance the image frame. You can also learn object tracking and face recognition using artificial intelligence such as deep learning. You will also learn how to design web browser using HTML, JavaScript, and web development framework. I hope this short video showcased the interesting modules that our Automation and Mechatronics System course students study. Please speak to our lecturers if you would like to know more about the course.